Thanks, Peter, for inviting me to do this, and thanks for everyone for sticking around here till the end. Before I get started, I do want to recognize Dan Mikauskis and Becky Redmond. They're two of our Lake Michigan program biologists, as well as Will Stacy Duffy, who's sitting right over there. He's an aquatic ecologist with the Illinois Natural History Survey, working out of our office. And these three are actually the ones that do all the sampling out on the lake, not me. I'm in the office all the time, but they do the sampling, they analyze the data, and they've actually made most of the slides that I'm going to present today. So appreciate that. Just as an outline, I'm going to go kind of from warm water fishes to cold water. So we'll start with nearshore fishes, go on to yellow perch, then salmon and trout, and then lake trout. And hopefully I don't go too long and we have time for some questions and discussion at the end. So for our nearshore sport fish assessment, we use a DC electrofishing boat shown here. And we sample every other week from early May through mid-August. We target sport fish, but we also collect other species, but there's a lot of fish out there, so we really focus on the sport fish. And we sample at 4 harbors, North Point Marina, Waukegan Harbor, Jackson Inner Harbor, and then along the shoreline at Calumet Harbor here. The fish are netted. They're put into a tank in the boat that has oxygen, keeps them alive, and then they're identified, measured, and weighed. And with the biodata that we collect from the fish, we can come up with a number of different metrics that helps us evaluate the population. And oops, wrong one. Well, there we go. And we can look at relative measures of abundance, that's catch per unit effort. We get an indication of what the size distribution of the population is, what condition they are, really how plump they are. It's a length weight relationship. And then in some years, we can get age and growth information. Katie talked about that with, we actually use otoliths as well in some of these cases. I'll present a little data for smallmouth bass here. This just some pictures to give you an idea of some of the fish that we get in our sample, some of the more abundant fish. So we have smallmouth bass, largemouth bass, a number of sunfish, rock bass, bluegill, and pumpkin seed. We also get northern pike. This is a baby, but usually we do have some reproduction, we think, going on out there, but normally they're around 17 to 40 inches long. There's some really big pike in the harbors these days. And then up here you can see Becky. She heads up the nearshore program, and she's holding a jumbo freshwater drum. Their populations have also, kind of increased quite a bit lately. And then we even have black bullhead population that would be considered fishable in Jackson Harbor. So we got a lot of variety here. Oop, going the wrong way. Okay, so I do want to present a little angler catch data, and this is from the Illinois Natural History Survey, Lake Michigan Biological Station's creel survey that's headed up by Charlie Roswell back there. And so this is some angler catch data for largemouth and smallmouth bass. And it's from 2013 to 22. This is the number of bass estimated to be caught based on the creel survey. And you can see 2 things to look at here. One is we've seen an increase in the catch rate in general since 2013 to 2022. And we also see the blue bars are actually smallmouth bass. The orange bars are largemouth, predominantly largemouth bass. So they're really the popular fish out there in terms of bass fishing.
Smallmouth, right?
Smallmouth. Did I say largemouth?
Yes.
I meant smallmouth. Sorry. It's not working again. And so getting to some of our survey data then, this is catch per unit effort, or the catch rate, the number of fish, smallmouth bass per hour. And I'm just going to present data for smallmouth bass for the next series of charts. And this is for the 4 harbors that we sample in the different colored bars. And what you see here is that we do catch smallmouth all up and down the shoreline at the different harbors, but they're definitely far more abundant at Calumet in the southern part of the lake. So seen with the blue bars there that represent Calumet Harbor. I'm not sure what's one more. There we go. And this is a length frequency distribution for the smallmouth bass in our 22 sample, and good range of fish out there from 3 to about 20 inches. We kind of break it down. You can see here we have number of juveniles in the population. That's a good thing. That means there's natural reproduction going on out there. We like to see that. We also have intermediate sized fish moving through. And then also the larger size fish that are, that's what our anglers are seeking. So it's good to see those too. And actually, when you look at the numbers, we have a good proportion of large fish in the population. So that's a good deal for anglers. Keep going the wrong way. This is an example of the data for the condition of fish. And you can see in the picture, Dan's holding a really nice smallie there. You see it's nice and plump, really healthy, in good condition, we would say. But what we do is you can plot the length of the fish on the x-axis here and then the weight on the y, and you get a distribution. Each one of these blue dots represents an individual fish. And this line is what we call a standard weight line. So that's kind of our target. So when you have a value like this one that's right on there, that would get a value of 100 in the relative weight world. If the fish are above this line, it would be over 100. If it's below, it would be under 100. And so our average for this sample in 22 was 107. So anything from 95 to 105 is considered really good. So these fish are in good shape. There's no indication that there's any, hey, possible. There's no, it's gonna have to go the other way. No indication that there's any food limiting going on out there. So there's plenty of food for them. And then I told you I'd show you a little data on age and growth. And this is for smallmouth bass. This was 2019. And the fish in that year, in the subsample that were taken, and these were aged with odorless, from 1 to 13 years old. Each one of these dots represents an individual fish. And this is just a curve that's fit to the data. So that's a typical growth curve where you see faster growth. It's steeper here. They grow faster when they're young, then they mature and they start putting energy towards reproducing. Growth slows, and then when they get older, they grow even slower. So this is pretty typical, and I don't have this in English, but this would be 16 inches. So if you come over, we see that the fish reach 16 inches in anywhere from 5 to 7 years. And for a cold water lake like Lake Michigan, that's pretty good growth. So we got good growth rates going on out there as well. And I don't have time to present data on largemouth bass, but just want to say similar results with largemouth in terms of the population indices that we look at. And we do have big fish out there. They're not quite as abundant as I showed earlier with the creel data, but this was a 22-inch, 7.5-pound fish caught in Jackson Harbor in 2018. So just to summarize then, for nearshore fish, we have a variety of sport fish and fishing opportunities out there in the Illinois nearshore waters. Smallmouth bass are popular with anglers, and they occur up and down the shoreline, although we're finding that they're more abundant down south in the Calumet region. And overall, the bass populations have been pretty stable over time, showing moderate abundance and good size structure, body condition, growth rates, and natural reproduction. And I'm going to move on to perch, another popular fishery out there. And we sample perch in 2 ways. We do an adult assessment with braided mesh gill nets. That's offshore gill net sets. We have 2 transects, one in Chicago at Foster Avenue and one up in Lake Bluff. We have a total of 11 depth stations for the survey, up to about 120 feet of water, 125 feet. And this survey occurs over 2 weeks in late May. It's a pre-spawn survey. And then we also do a young of the year survey shown here. So we try to index, recruitment of these fish. When they, what perch do is they get advected as small fish offshore. They feed out there for a while, and then they come back in when they get to be about 2 inches long. And that's when we start sampling, usually the first week of July, sample weekly from July through early September at 5 beaches along there with a 30-foot beach seine. And I'll present some data from these. And so this is our adult survey first. And so this is the number of adults at our 2 different stations here, Lake Bluff and Foster Avenue, and the different colored bars. This is catch rate. This is number of perch per 100 foot of gill net and from 2002 to 22. And you can see just basically a decline in perch abundance over time. We had some really lean years, like you were talking about, Katie, in the mid 20 teens, I guess. But we have seen a little bit of an uptick. It's not tremendous, but at least it's nice to not see this anymore. We're actually getting some adult perch that we can collect some data from. 2020, we didn't sample. That's why that's a blank. That was because of COVID. And Dan, he's our perch guy, and he ages perch with otoliths too. And this would be these are the adult perch, and again, it's relative abundance of these perch, and you can see from the 22 sample, we had fish age 1 through 7. This is pretty typical distribution where the younger fish in the population, the younger age fish shown here, they're going to be most abundant. And then as mortality over the years kicks in, you get a basic drop down in the numbers of fish as you get older. Pretty typical. This is kind of unusual to have a a blip up like this. And these are age 6 fish that was where I said they had the 2016 year class was a pretty substantial year class. So it's showing up there. And when you age the fish, you can also then determine growth rates by looking at the length at age. And what we see here, this is a long-term data set. We can look at a bunch of different males and females and things, but I'm just going to present this the age 2 male data here. And you can see back in the 90s, pretty good growth rate. 100. This is around 6-7 inches long as age 2. So they've had 3 growing seasons in the lake. Then you can see when things really got pretty bad in the early 2000s, they're only a little over 4 inches, 4.5 inches maybe. But then in recent years, this was kind of surprising, especially this year, we're over 8 inches. So we got in 22, we got 8-inch perch that are only 2 years old. So that's even higher than we had back in the 90s, which I don't know how that's happening, but they're getting on fish, they're finding something to eat, and they're growing pretty well. So that boat, we hope that's a good for the population. Maybe more fish. If they grow fast, they get on fish, then they stay on fish and they get bigger, recruit to the fishery, which is good. And hopefully we'll have some more adults out there. They also avoid predation too. So that's important. And then this is our same data. So this is the young of the year perch. What we see, you also kind of alluded to this, I think, in your talk, where we used to have. So what we have here is from 1978, this has been going on a long time, all the way to 2022 along the x-axis there. This is just this is the number of perch per seine haul. And these young of the year fish tend to range from like 2 to maybe up to 4 inches later in the sample if we get them, maybe 3. But back in the 80s, we're looking at really consistent recruitment in year classes. And that's kind of what you need to build up those population of adults and keep that fishery going. And then in 1990, pretty much nothing up to, through 2000, very, very few, except for 1998. Now, this was a year class that proved to be a really big year class. It supported the fishery for a bunch of years. The fish just didn't come in. We didn't get them, over the summer. What's that? It was fantastic then, yes. That's what fed that Waukegan fishery you're talking about, was that 1980 year class. Yep. Yep. But here's what we got now. It's just really, it's not consistent. We get good spawns maybe once every 5 years. And so we're just not seeing that consistent recruitment that we need to build the population. And even like here in 98, we didn't catch them, but that was a good year class. And in 15, there were perch everywhere. I don't know if you guys remember that year. They were in the diets of all kinds of fish. They were just all over the place, but they didn't really build up the numbers in the population. They just didn't, recruit like we would hope they would have. I want to present some more of that creel data from the Natural History Survey, and this is perch harvest during the summer, and it kind of mirrors what we see. This is from 2010 to 2022. And this is thousands of perch. And this over here, so that's the blue bars, a number of perch. And then this orange line is actually the hours fished. So you can see we used to have a lot of perch effort out there, and a lot of that was shore fishing. And that's kind of gone away in recent years here since about 2015. big reductions, kind of what we're seeing in our assessment, those Gillnet surveys, and really low in the last couple of years as well. But what we're seeing is an increase in perch harvest in the winter. I don't know if it's an increase, but it's definitely a lot bigger than what we're seeing in the summer. There's always been a winter fishery, I think, but definitely higher. It seems like higher numbers in more recent years, and higher effort too, at least in the tens of thousands of fish and the tens of thousands of hours. So it's just something that's changed. It's a shift, and the perch just aren't coming in the summer and sitting near shore where people can catch them. All right, there we go. So then to summarize, adult perch catches remain low in our annual surveys. Recruitment of young of the year is inconsistent compared to the 1980s, and recruitment to the adult stock remains low even in some years when we do see the little ones. Growth rates for perch have improved in recent years, and we're hoping this bodes well for the future of the fishery and the population. And perch angler harvest and effort has been higher in the winter than in the summer. So moving on to our salmon and trout fishery, and this is kind of the big money fishery, I'd say. We just heard about the economic value of these the fishery, and these fish are maintained largely through stocking. We are seeing some natural reproduction I'll talk about in a few minutes, but they're maintained largely through stocking, and the stocking is done by the state agencies primarily for these 5 species. You can see we stock in Illinois. This is Illinois numbers. What we're proposing in 23, similar to what we had this year. It's about 750,000 fish, and those fish are raised at the Jake Wolf Fish Hatchery, really downstate on the Illinois River. It's just a great place to raise salmon and trout based on the aquifer that's available there and the amount of water. And then the lake trout are raised by the U.S. Fish and Wildlife Service, and their stock, we get about 120,000 of those a year. And this is highlighted in green because we are proposing to do an increase of about 30,000, a moderate increase of 30,000 Chinook salmon for 2023. And we stock at 11 sites along the shoreline, so mostly at public access sites here. I think they're all public access really, but we try to spread it out as much as we can. So three sites, Coho salmon and Chinook salmon are stocked at 3 sites, Jackson, Diversey, and Waukegan harbors. Steelhead, Skamania steelhead trout are stocked at Jackson, Diversey, and then we actually just started stocking in North Point Marina in 2020 to try to establish a population of steelhead coming back there. We stock early rainbow trout at 6 sites. All 11 sites get brown trout. And then again, Fish and Wildlife Service stocks out at Julian. We do offshore stocking for our lake trout out at Julian's Reef. This is just a graph just to kind of give you an idea of what we stock, and you can see the different colors represent the different species in the bars. This is from 98 to 2022. And really the takeaway here, aside from Chinook salmon, which we've had to adjust a bit over the years, pretty consistent stocking for the other species, except if this works, yeah, except for those 2 years, 20 and 21, that was because the service wasn't able to make it to our waters to stock the fish because of COVID travel restrictions. So those fish were actually stocked up in northern Wisconsin. Focus a little bit on Chinook salmon. That's really the prize fish out there. You can see, I mean, they're big fish. They grow fast, kind of a super predator out there. You know, this fish is getting this size in 4 years of, in the lake. So they definitely, to get that big, they have to eat a lot of fish, and these guys eat alewife almost exclusively. So we've had to make some reductions in stocking starting in 1999 here. This is our Illinois data, but this was a lake-wide stocking reduction in 99, 2006, there was another one. 2013, there was also one. We didn't take a big cut there. A lot of those came out of Michigan because it has to do with wild fish, which I'll talk about in a second. 2016, we all took a pretty good cut. Kind of stayed there, and things got a little better in more recent years. So we actually did an increase of 30,000 Chinook in 2020, And then we're proposing another increase to 210,000 in 2023. So I just want to take a minute to talk about, what's some of the data we use to make stocking decisions on how we're going to adjust things. And one of the reasons we made those cuts in those early years is because we found out that there was a lot of natural reproduction of Chinook going on in the lake, mostly in Michigan and the cold water streams over there and up out of the north. And so when you have, you can look recently here, we're looking at the 7 to 8 million smolts, being stocked. And you can see what the orange here is what we stock. I'm sorry, smolts being produced naturally. So the blue is the natural wild smolts, and then the orange is our stockfish. So, we don't want to overpopulate the lake with predators. So that's why we were making some reductions. I do want to mention that this is U.S. Fish and Wildlife Service mass marking data. This is a great program where they mark fish that are, a lot of fish that are stocked, including lake trout, Chinook. We're now doing a study with steelhead. So we can see there's actually natural reproduction going on with steelhead too now to a pretty high degree. So move on. Another reason why we made reductions back in the day was because we're concerned about alewife abundance. Really, since the 70s, since the Clean Water Act is cleaning up the lake, the abundance of alewives has slowly been declining just in general. And then when we got the mussels in there, it kind of came down even faster. So we have a general decline in alewives to where we're concerned about the population being able to maintain itself. So we look at not only the abundance of alewives out there, but also the age structure. You can see in some of these years when we made some cuts in recent years, we're looking at mainly age 1 fish. So we got one big year class out there feeding all these predators in the lake. And if they eat those fish out, if they eat them away, then there's no adults. You don't have that spawning population to keep the population going. So we don't want to have a crash. That's what we're concerned about. And we're not just making that up. That actually happened up in Lake Huron in 2004, where the alewives were wiped out. And then a couple of years later, that was the end of primarily the end of the salmon fishery. And so as managers, we try to manage for balance between the predator and prey fish populations. And so, like, if we have too many predators here, they're going to consume a lot of the alewives. You're going to see this balance shift like that. So you don't have enough prey out there. And what we've seen in like 2015, these fish get thin, they get small, they don't grow as fast, and they also get thinner and just not as their condition goes down. And then if you had too few predators, which I don't think we've seen recently, but then your alewife population here is going to go up. And then we're going to get back to the situation we had like in the 60s, 70s, for those of you that were around back then, where there's just dead alewives in the spring on the beaches. I mean, front end loaders and dump trucks to get rid of them. It was crazy times. I remember it as a kid, but we don't want that to happen. And then also, as Katie mentioned, when the alewives get abundant, they have an impact on native species like perch and lake trout. So we want to keep a balance going here. And our Lake Michigan Technical Committee, the Salmonid Working Group, they developed, along with the Quantitative Fisheries Center at Michigan State University, what we call a predator-prey ratio. So basically what they do is they're using statistical catch-at-age models to estimate the abundance of Chinook, or the weight, total weight, biomass of Chinook salmon in the lake, and then also the total weight, there's another model for alewife to estimate their abundance. And the ratio is just the weight of Chinook salmon divided by the weight of the alewives, gives you this predator-prey ratio. And we have a target of about 0.05 for the predator-prey ratio, and that's 20 pounds of alewife per 10 pounds of Chinook. That's what we're kind of stay around there. If we get up towards this upper limit, that's a 0.1. That's only 10 pounds of alewife in the lake for every pound of Chinook. So if we look at just quickly at the data, you can see there's that decline we've been talking about over time. But we hit a low here, but then recently, after we made some couple of substantial reductions in predators, they rebounded a little bit. So that's good to see. And this value of 100 kilotons of alewife, that's something we'd like to stay around or above. We don't want to get too far below that like we did back here in 2015 and 16. And we also are looking pretty good with our predator prey ratio here. So that's one reason why we're considering moderate increases in predators in the lake in the last few years. We don't trust models totally because they're models, it's math. So, I mean, that's a good indicator, but we also have auxiliary indicators, which are based more on the basic data. And this is data from around the lake, from all the jurisdictions. It's not like it's just one location, but we have a couple of indicators that look at the condition of Chinook, the Chinook. We have a couple of indicators that look at the harvest, both charter and non-charter. And then we have a couple of indicators that look at, which I talked about a little bit already, the Alewife population. And what we have found over time is that second indicator, the weight of the age 3 female Chinook returning to weirs and harbors, has been really good at giving us an idea of what's going on. It tracks inversely with the predator prey ratio pretty well. And I'll show you some data here from that. This is lake-wide data then, produced by the Salmon working group. And so this just shows the average weight of an age 3 female that's coming back to the weirs and also from our fall harbor surveys. And you can see that we had some tough times here in 2000, early 2010s. We don't really want to get below 15 pounds is a value we're looking at. In recent years, though, you guys that fish out there, you know there's been a lot of big Chinook out there. So we're up here in the above 18. This is where we want to be. We peaked out at over 22. That's a pretty high average to have a 22-pound fish as your average returning H3 female. And we did see a little uptick recently in this year, but we're still above 18 pounds, so we're feeling pretty good about that. So that's enough on the whole stocking issue. I'll go ahead and present some data now. And this is angler harvest data. Again, we got two ways to look at this for the salmon and trout. One is our recreational harvest, the natural history survey, creel survey. And then we also, charter boat captains are required to provide monthly reports on the number of fish harvested as well as the effort. And so this is a little bit busy, but basically what we have, this is the recreational creel from the survey. And you can see the different fish are each in a different color here. This is angler hours here, which is reflecting what's going on with this dashed line. The bars are number of fish harvested. So pretty good numbers of fish, but the two takeaways that I want you to see from this data is all the green there, that's coho salmon. Coho salmon are the predominant species harvested in Illinois waters. That's not true around the lake, but that's the way our fishery is. The other thing is that we've seen kind of a gradual decline in the number of fish harvested and also in the effort in recent years, in the last decade. And I'm going to show you pretty much the exact same graph with the charter data. Pretty much a similar pattern where coho are the most harvested fish. And then we also see that gradual decline even in the charter data for both the effort, the angler hours, as well as the numbers of fish harvested. One thing different for the charter fishermen is you can see the white bars here. Those are lake trout. They harvest higher proportion of lake trout than your recreational anglers do. Part of the reason for that is that lake trout are around, they're more of a local fish and they're always around. So the big salmon, they can move all over the place. Even the cohos, they can move all over the steelhead. So if they're not around, you can always turn to lake trout and catch some fish. And then here's a measure comparing charter fishing, which is the red bars here, versus the non-charter anglers. And this is catch rate. So this is number of fish per 100 angler hours. And what we see is that the charter anglers are more efficient at catching fish. They catch more fish in a given amount of time than the non-charter anglers. That's not true of everybody, right, Andy? But
thank you.
Yeah, but this is the average. Long-term average is 44 fish per 100 hours for the charter captains. And you can see in recent years we've been actually doing pretty good. And when you talk about catch rate, that's really like an indication of the quality of the fishery, how long you have to fish to catch those fish. And you can see here, even with the non-charter anglers as well, that we're above the long-term average. So, and we can follow this line. We don't only went from 2008 to 22, but we can go back and it's pretty much the same. The catch rates stay pretty consistent over time, which is pretty crazy. We also sample fish in the fall by electrofishing, and these are returning fish. These are mature fish that return to the harbors to spawn where they're stocked, and we sample from mid-September to mid-October, and that's a weekly survey with the electrofishing boat. And we do North Point, Waukegan, Diversey, and Jackson. These three are our stocked salmon harbors. And just to give you the data up front here, the results, we got higher catches in 2022, and we also saw larger size fish in 2022. So this is the catch rate data in electrofishing, the number of fish per hour of electrofishing, and here's that 2022 data. You can see it's up here. It's actually back kind of similar to what we saw back in the early 2000s. But that was kind of a surprise to see that, because we have been having fairly low returns for coho salmon here. And the fish were a little bigger, like I already said. This would be like an average size coho in the fall. That's around 20 to 22 inches long. And if we look at that size distribution from our electrofishing samples, you can see that the mode here was actually 24 inches. So bigger, a little bigger than average, typical, but this is kind of interesting. We did have a number of big fish all the way up to 32 inches, and those would be these guys. Those are some big coho salmon males. So how do they get this big? Well, Dan dug around in the data. This is actually kind of cool. Something that, if I can get it to click, there we go. And you look back at the 2021 electrofishing data for the fall harbors, and you could see from that earlier graph, not as many fish were caught in 2021. Not as many big. You don't see the big fish here either. But this is, they have this mark, yeah. This is what's kind of interesting. Those are age 0 fish down there that got enough to eat, decided that they were going to mature and come in and try to spawn with the big boys in the harbors. And give you an idea, that's what these guys look like. So those are age 0 fish. They were stocked in May. This is in September. So that's pretty good, quick growth rate. And to grow this fast, they got to get on fish. They're not going to be doing that feeding on shrimp or insects or something like that. So they're probably feeding on alewives is what I would project, because coho do primarily feed on alewives just like Chinook. They can vary a little more than Chinook, but they do. So if you look at our prey predator, or I mean our prey fish samples that are done, these are actually done by the US Geological Survey, and they have an annual bottom trawl survey and acoustic survey. And what we see here, and this is young of the year, so this is young of the year alewife this is the 2022 survey. But you can see in 2021, pretty good numbers of young of the year alewife. So those little coho were able to get on these, feed on those, keep growing. And then you see if we go to 22, these are age 1 and older fish. So you can see that even blipped up to pretty decent numbers. Now, this is not huge numbers by any means, but it's at least average, I'd say, or maybe a little above, a little below average. That's billions of fish out in the lake, by the way. And then this would be the next year, the numbers came up as well. So if those coho can get on these and grow, and we kind of get an indication that they're growing well when we see those jacks come in, and then that allows them to stay big enough to feed on that year class as they get older. And then they can grow and we can get those really big fish. And this is all I have in terms of Chinook data. It's the same, this is from the 2021 distribution. And again, these are a little bigger because they're Chinook, but these are age 0 Chinook jacks that came in to spawn in the fall of their first year of life. So if the same holds like we saw with the coho, we could expect some pretty good size Chinook and hopefully some decent numbers this year in the summer, as well as next year. They'll have another, that year class will have another year in the lake before they age out. So to summarize, with consistent stocking and more recently natural reproduction of some of the species that we're stocking out there, they've contributed to support a popular and diverse salmon and trout fishery. Coho salmon are the predominant species that get harvested in Illinois waters of Lake Michigan. We've determined that we could have moderate stocking increases of Chinook salmon and steelhead. We raised those in 2020, and then we're proposing another increase in Chinook in 2023 of about 30,000 fish, and that's to bolster the late summer and fall salmon fishery. And we seek balance between our predator and prey species. We think that's key to sustain these fisheries, and we appear to be in reasonably good shape based on our data in recent years with the PPR results, the Alewife biomass estimates, the weight of the age 3 females returning to the weirs and harbors. 5 minutes? Okay. I'm just one more species to go, and that'll be lake trout. And this is the state record lake trout for Illinois that was caught in 2021. Again, start with some stocking numbers. Main thing I want you to see here, a lot of stuff happened back in the day, but since 2008, we've been pretty consistent, stocking 120,000. I should say the Fish and Wildlife Service has, raising and stocking 120,000 yearlings out at the reefs. There's that missing data, again, due to COVID. But on a lake-wide basis, we've actually been reducing the number of lake trout stocked in the lake. Again, has to do with natural reproduction and desires by some agencies to have more Chinook than lake trout. But you see that the federal hatcheries kind of geared up and got up to about little over 3.5 million fish back in 2007, stayed pretty consistent till about 2014, 2015. And that's when we realized that there was natural lake trout reproduction happening. So we started reducing numbers, and now we're sitting at about 2.2 million. And of that, about 1.4 million are actually stocked in the northern refuge, which is way in the northern part of the lake. We sample lake trout with 2 different assessments. One's a spring Gillnet assessment, and that's a part of a lake-wide assessment plan. All the agencies do it. It's a randomized assessment, doesn't target lake trout habitat. There's 2 transects off of Waukegan, or between Waukegan and Lake Bluff, randomly select 2 transects and then sample 3 depth bins at each one of those from 50 to 200 feet. And then just looking at some of that data, I'll show about a couple slides like this, where you have catch per unit effort, number of fish per 1,000 feet of Gillnet over the years on the bottom here. And you can see we're averaging in the spring assessment, probably about 12, I'd say, fish per 1,000 feet of net. And in our strategy to restore lake trout, we have a target here of 25 fish per 1,000 feet of net. So based on the spring assessment, we're not there for sure in terms of lake trout restoration. But we are seeing wild fish in the spring assessment. It started in around, I'd say 2011, when we got above these low numbers. And then we kind of going up. We're up to about 35% of the lake trout sampled in the spring are wild. And in the fall, we have this is a spawner survey that we do out on the reefs. That's in October and November. That is targeting habitat. Waukegan and Julian's Reef are the ones we sample most. There's 8 gillnets. We try to sample the top and the slope of the reef. And here's the data for that. We have a higher 50 feet or 50 fish per 1,000 foot of net is our target in these spawner surveys. And you can see for the whole data series, we've pretty much been above that. So out on the reefs, we built up enough of population of adults to meet that metric. And even we've sampled some additional reefs in recent years, and those fish, they were there too. And in wild fish, also seeing an increase. It started earlier out on the reefs, maybe 2008. And then we peaked out at about 80 fish in 17 and 19. We're down around 50 to 75% of our sample is wild. So there's a lot of natural reproduction going on in our water. And we are able to determine the ages of the stocked lake trout because they're part of this mass marking project with coated wire tags. These little metal tags get injected in the snouts of the little baby lake trout at the hatchery. And then they have a code on them, and when we catch fish, we can extract this tag, and then we can, that'll give us the location, the year, and the strain of fish. So that's useful for the stocked fish, but when it comes to the wild fish, we don't have that luxury. So we have to age them using some type of hard structure. We've looked at otoliths, and they just don't seem to work well with lake trout. They're a slow growing, long lived fish, just doesn't work out as well. So Will and Becky and Dan are working on coming up with a technique. It's been done. It's not like we're creating this, but they're working with developing protocols so that we can age these fish with the upper jawbone. And it's with that, you take the bone, you clean it, and then you section it, and then you get a cross section, like use a saw, and then you put backlighting on it, and you can see the rings, kind of like you were talking rings on a tree. And this happens to be a known age. We're starting with known age fish, so we have a reference. And so this fish is 10 years old. And then I'm going to end my talk here showing you the maxillary, the jawbone of that state record lake trout. I don't know, take a guess or count the rings. How old do you think this fish was? 38? Oh, while you're still thinking, I just want to recognize Tom Wendell. He's a taxidermist that did the mount, and he's the one who contacted us and got us the head so that we could do this. But actually, we think this fish is 29 years old. So it was stocked in 1993. What's that? Weight. The weight of it? 40 something? It was a beast, yeah. I'd have to look it up. It's in our reg booklet. I can't keep all those numbers in my head though. So with that, hopefully, I know I went long, but hopefully we have time for a couple of questions. That's our Gillnet tug that we contract. That's how we do our net sex offshore.
We do have some time for questions. It is 8:23. So we are scheduled to go to 8:30. I'm not sure if we can hang out a couple minutes after that at the club or not. But we will try to keep everybody on schedule. So it's about 8:23. Ask questions. I also left some surveys on the chairs. It'd be great if you could fill those out. Pens in the back if you don't have them. So with that, questions?
No questions? Oh, we got some questions. Oh, go ahead. Let you go first. I'll get to next.
Just as an observation, two of the graphs we showed, one with the being of perch in 2015 and 2016 showing the speed.
Yes.
And then you saw the Alewife trend at
A low?
a low.
Right.
So I guess maybe it is a question. Is there a correlation between the two? Because are they competing for the same resources to grow, or is it just that one is, or is it just a coincidence?
No, what we usually see when it comes to you have to understand that that declining trend is all ages of alewife. It's not just age 0. So you're kind of indicating like what happens with those age 0 fish. Do they compete? I think what we really see is they're similar. They have small larvae, they come up, they spawn near shore, then they get advected, both species, they get advected out into the lake, and they kind of feed on plankton out in the middle of the lake. And then, the perch come back in, the alewives kind of do their thing. So usually what we see is when we have a good perch year class or a good alewife year class, same with both those species, will kind of go in sync together. Yes. But the overall decline has to do with what Katie was talking about with the impacts. First of all, the Clean Water Act has cleaned the lake up tremendously over the decades. But then when the zebra mussels came in, I think it would be really fine if we didn't have the zebra and quagga mussels. The zebras whacked the perch early. You saw those years where we hardly saw any recruitment. And then things started to get a little better. It seemed like in those early 2000s, and then the quagga mussels kind of came in, and then, the zebras were kind of, they're just near shore, so they're affecting the near shore where the quaggas are. If I could show you some graphs that the USGS, the EPA has, that they're covering the whole lake. So they're having major impacts on the entire ecosystem and disrupting the food web too. Diperia used to be out there in crazy abundances, 10,000 per square meter, and they find them in only a few locations anymore, and their numbers are really down. And that was a high energy little scud, little shrimp that everybody ate. So that's had an impact too.
Oh, yeah,
I hope I answered your question. Okay.
you mentioned the alewife population in the Coho, the balance there. Don't wanna have these alewife wiped out, so.
Right.
My question is, when you make these decisions about stocking, you consult with the DNR in Michigan, Indiana, and Wisconsin?
Yes, we have a process for that. It's through the Great Lakes Fishery Commission, and we're all part of a joint strategic plan for managing Great Lakes fisheries. We've signed on to that at the higher levels of our DNRs. And I sit on, and then it's there's lake committees. So each of the 5 Great Lakes has a committee of managers. So I'm the manager for Illinois that sits on the Lake Michigan committee. Dan and Becky, who work for us, they're on the technical committee. They collect the data, help analyze the data, and provide us with information, and then we try to make decisions. So it's definitely a formal way of doing it, and it's important because up in Michigan you have tribal entities. You know, we have CORA, Chippewa Ottawa Resource Authority, and that's, I think, 5 tribes. In the other lakes, there's Gliffwick, there's the 36 treaty. So we have a lot of authorities that have management, authority on these fisheries. So that process works pretty well, I'd say, most of the time, and we'd kind of be lost without it. Back before they had it, everybody just did whatever they wanted and didn't worry about everybody else. But we know now from that mass marking project, Chinook salmon stocked anywhere, get caught anywhere. Our fish get caught all the way up in the northern. If you think about like Chinook and Coho, I mean, they go out in the ocean to feed in their natural environment, and it's as big as they may cover areas big as all the Great Lakes combined. So for them to move across the lake or something, not a big deal. And I think we see it happens if we don't have bait here to attract them, they may not be around. So.
Do the other states use similar measurement tools to decide on stocking like you do?
Yeah, that's the Lake Michigan committee that I was talking about. There's a representative from each of the 4 states around Lake Michigan and the tribes, the CORA group. And we have that technical committee. And so they provide that data, even the USGS with their surveys and things. I mean, that's all presented to us at these technical committee meetings. So yes, we're all looking at the same data, but we all have individual interests, right? I represent Illinois fishermen. And so I have to look out for their needs and what's big for us. Coho, is big for us. If Michigan didn't stock 1.5 million coho, we wouldn't have the coho fishing that we have. So I can't tell Michigan what to do, but we do work together to make sure that we all, benefit from what we're doing. So.